ladies and gentlemen, I believe we can begin our meetup. As always, it is my pleasure to welcome you to Mobile Warsaw and to our 25th meetup. And I would especially like to give warm welcome to all the newcomers here. Who hasn't been here before? Raise your hands. Quite a lot. Cool. So for the people who have not been here yet, we always have official sponsors who pay for the beer, which you can order over there at the bar. And our official sponsors are Allegro, so give it up to Allegro. Woo! Mobica, so give it up to Mobica. And El Passion, who's paying for the video recording, which you will be able to watch later on YouTube on our channel. And today we have a small surprise for you. Who knows what this is? Who's using Slack? Raise your hands. I think about 5 people did not raise their hands, so I'm pretty sure everyone knows what it is. I'm really happy to announce that we have an official Slack Mobile Warsaw channel, which you can sign up for using this beautiful link over here. And we'd love you all to sign up so that we can be closer together as a community and that we can exchange ideas over there. Go ahead and visit this link. You just have to give your email address and you will receive an invitation. And of course, we have goodies which you can win, which is JetBrains license. If you want to participate in the lottery, go visit that guy. And t-shirts, yes. How many t-shirts do we have? 2? Krzysiek? 2 t-shirts, yes. And now, Antek, I believe it's your part.
Hi. So, welcome. And as always, if you think you know someone who would like to speak here, or maybe you would like to speak, please just contact us. We are very good at convincing people to come here. Also, if you don't have a full talk, but you have a very small topic you would like to talk for 5 minutes to 10 minutes, also it's welcome. I think fresh talks are pretty awesome. Yeah, as said before. And as always, if you have other suggestions, like a nice venue, something to think, maybe some Slack ideas, we'll happy to hear you and maybe figure something out. So, one more thing about the goodies, please catch me in the break or at the end of the meetup, because after the second presentation, we will do the lottery. Good. And that's it. Thank you very much, and have a great meetup.
Hello. Hi. My name is Marcin Krzyżanowski. I'm here to talk about cryptography I've been doing lately. And, well, the title is Crypto Binder Than That. I will present you my recent work in that area. There will be 3 projects. So, who of you know who the Edward Snowden is? Everybody should know. Well, so Edward Snowden is an American computer professional who leaked classified information from the NSA. Well, the leaked is a big deal. This is the guy who showed the world how big a surveillance of the American is. This is the Edward Snowden. And not everybody is happy about what he's done, especially this guy. Snowden I don't know where he's currently, somewhere in the world, but he cannot return to America. So he leaked. He leaked the ultra secret documents to the journalists from the NSA. And as you can imagine, it was extremely risky operation. So, of course, he was scared. His first try to send the documents and to communicate over internet was PGP. It's a very old stuff, but I will talk you more about it. He even prepared a tutorial, video tutorial, for one of the journalists. This is the Greenwald, and this is how it looked like. It was a video. This is 12 minutes, and it's very long. I will not show you everything, but it's just to give you a point of view how this tool looks like. So I have made some screenshots. So you have to download. You have to choose something. I don't know what it is. There's a Cleopatra and GPA something. Now you have a GPA Cleopatra. At some point he said, "Oh, you should use Cleopatra because the other way. You should just use GPA because the other one is too hard to use." In my opinion, both are too hard to use. This is how it looks like. So at first he had to generate the key, journalist, and do some magic, and upload the key to the server. I believe this is this journalist during the watching the video. Then he had to copy paste the key from the servers, paste it to the clipboard, do something, yes, copy, paste it to the email client, and at the end, this is the Greenwald. He completely refused to use this tool. Later on, he said, "I didn't really know what a PGP was," he admitted. "I had no idea how to install it, how to use it. It seems time-consuming and complicated." And it was, in fact. In generally, I fully agree. PGP is a no-go for a regular user. It's not even about the concept of PGP, but it's about the tools we have. So PGP is a geek tool. I believe this is a geek tool. Do you know anybody who uses PGP on a daily basis? Okay, there's one guy. Is anybody of you use PGP? Not at all. Okay. It's because the tools are built for nerds, right? There's no good tools, and by nerds for nerds. One of these such a nerds is Werner Koch. He was famous lately because there was an article that the world email encryption software relies on one guy who is going broke. This is the guy behind GNU-PG, the command line tool, and well, he's quite old, but he still maintains this tool. Turned out he didn't have money. Actually, after the publication, some company raised a hand and gave him some money so he can still maintain the project. And this is the contribution of Werner Koch lately to the GNU-PG Git. You can see there is Werner Koch and almost nothing else, right? So he's the only, I can say, he's the only maintainer of this project. I don't know, it's 10, 20 years maybe now. Okay, so is it good, this PGP? As I said, we can ask NSA. For a minute, we're back to Snowden. Why Snowden actually chose PGP to communicate. Recently turned out that NSA is afraid of two things. The first is AES, this is the Cipher, Advanced Encryption Standard. This is the award-winning algorithm that became the standard in 2001 and is very secure, very popular. It's used all over the internet. It is so popular that at some point hardware vendors start to add instructions to do operations on the matrix that are necessarily to calculate AES. So it's so popular. It started by Intel, but it is available in the ARM lately, version 7, I believe. Some of the observers are worried that the NSA may actually broke the AES. It's just a rumor. I don't think so, but well, if we have a problem. So AES is a symmetric algorithm, and as such, it's using the shared key. To encrypt data, you need to have a key, and to decrypt data, you have the same key. So you have to somehow give that key to the other person. It's not easy if you can meet the person. You have to send it somehow. You can't use Gmail actually, but you have to figure out. If it's leak, well, everybody can decrypt this information. And the second thing is PGP. NSA states that no decrypt available for these PGP encrypted messages. And this is why Snowden used PGP to communicate with journalists. The PGP basics are like this. There's the Alice. There's the rabbit. And Alice wanna send message to the rabbit, right? So Alice have a public key. I know it's visible. And a private key. Rabbit have a public key and a private key. This is essential. The public key and private key is essential to PGP and to RSA and this asynchronous encryption. So whenever Alice wants to encrypt message to the rabbit, she takes the key from the rabbit, use it to encrypt data. Then rabbit use his private key to decrypt the data. This is how it works. So simple. In addition, the PGP offered the signing message, so there's no encryption. It's just information about who sent it, actually, right? Who sent it? It's a proof that this was sent by Alice, and nobody modified it in between. PGP is quite old. It was created in 1991 by Phil Zimmermann and proposed as a standard in 2007. So it's 16 years later. It was updated a few times since then. Today, PGP is 24 years old, yet the best on the market to end-to-end encryption. Google chose PGP to build the end-to-end encryption lately. There's an extension in Chrome, I believe. And PGP stands for pretty good privacy, that's the name, and it's a protocol. This is important. It's not encryption algorithm, it's just a protocol. So define the messages, how to build the messages. As such, it encapsulates many encryption algorithm. With PGP, there is a concept of web of trust. This is the fundament of PGP. It means that there is no single place, site, organization, or authority who authorize binding between key and the owner. So there's a key, there's a person, and well, there's no authority who say this key is yours, this key is mine. Concept is built this way that everybody can actually authorize another user. So there are the signing parties. It's not really popular today, but it used to be, where the user met, like we today, and sign their keys with the software, of course. After the key is signed by another user, the sign is there with the key forever and means this is you, because that guy said so. This is how it works. So what's inside the OpenPGP? This is the list of predefined symmetric ciphers. Historically, the list is long, and today mostly AES is in use. Today AES, the idea is not in use in GNU-PGP, triple DES is old, and so on. Hashes, list of predefined hashes. There's a places in protocol where owner of the key can decide which hash function is preferred and should be used to encrypt or decrypt messages. Today is the SHA-2 mostly. And the public key algorithms, predefined list. Today RSA, the rest is not used. Elliptic curve is not yet actually. It's not yet in use. It will be, I believe. There's rumor that OpenPGP.js will implement this algorithm soon, so it will be in use. Some believe it's better than RSA. There's an interesting thing that I have noticed. This implementation should implement RSA. It's not required actually by the standard. Today, I don't know why, we shouldn't use anything else. Maybe elliptic curve. Elgmal and DSA is too old. So there is a poop inside. When it comes to OpenPGP protocol specification, I found it rather hard to implement. And you'll see what is hard only after you start doing it. There's a quote from one of the quotes from the specification, PGP 2.6, this version has many variants. PGP 5 is something something. And GNU-PGP don't include RSA public keys, may or may not have, depending on version, support for IDEA or other incumbent algorithms. You have to care about everything when you implement the PGP because they really care about backwards compatibility. It's really a pain in the ass. OpenPGP as a protocol is built on the packets. There's a 17 packets, like a keys, subkeys, signatures, subsignatures, and data packets. They create a message, after all. There's 12 variants of signature packets, so the single packet have a 12 variants of himself. There's a 7 variants of key packets, 9 types of messages, and every of the 17, 12, 7, 9 can be in one of the 2 versions, version 3 or version 4. And it was not enough, because every packet, all that can have a header old format or new format of header. Really, there's a lot of if you want to implement this stuff. Of course, there are hard-coded values defined by the specification. A lot of exceptions, like when I worked on it, I thought I will focus just on the new version and build everything that is the newest. It's not the way. It's not going to work, because at some point you will find out that, well, okay, you are using the new version, but to this function you have to calculate it in the old way. So I had to implement the old way. How do I know all of that? I was there. And I implemented OpenPGP for iOS with the project Objective PGP. Why? Because I can, and I was curious at the time, and because there is really no choice on iOS. GPGME, spin-off of the GNU-PG project, has a license issue. Right? This is the GPL project. As such, cannot be used by the application published with the App Store. NetPGP by NetBSD is a decent implementation, written in C. However, it's not maintained. It's crashing. I've tried to work with it and give up after a few tries. I even built a project that is a wrapper around the NetPGP. So Objective-PGP is native implementation. It means it is written in Objective-C and with foundation. So all the classes like NSData and so on are in use. And what I have learned during the implementation is that PGP is actually hard to implement. It's very extensive specification and full of pitfalls. However, PGP is good. Aside from problems and complications, there is a lot of clever construction to keep data consistent and hard to unauthorized modification. So why not give it a try? And it was for fun implementation with sleepless nights. After a few months, I decided to release it to the public. You can find details on my blog. I decided not to release sources. I have my reasons. It's a bit weird that I feel I should explain why I didn't release sources actually. I didn't. Get over it. Library is free to use, and in a blog post I said, if you want to contribute, let me know, I will figure out. In fact, I had some inquiries about the sources. A few people saw the sources, yet no contribution at all. Today I mostly maintain the library. Actually, I have a new version on the branch, but it's not ready yet. I'm trying to steer clear of traps that I feel that I fall with the first version. I believe it will be better someday. On the GitHub, on the issues, a lot of people ask for sources. I say no, because I don't believe they really interesting contribution. And there is no contribution because people believe it's hard. And because companies don't have a budget for components. I had a few conversations about, okay, I can give you the components, I give you sources, okay, just some rewarding, not a big money, but then they decide, okay, well, you know, we don't need PGP. So this is an example of one of the GitHub issue about the missing sources. Close it. And there are questions about compatibility with Bouncy Castle. Bouncy Castle is used on the Android. And of course it is compatible. There's one word for the Android developers. Most of Android developers, I don't know, because I don't know the Bouncy Castle in details, use it in a way that may be not compatible with the standard. It is, there's always two keys, two public keys, two private keys. Let's say two public keys. There's a key and subkey. Main key is used to sign. Subkey used to encrypt data. And it is specifically set in that key. But it not have to be used. Of course, if you can use the main key only, that will be fine. But not always. Sometimes implementation will check if you use the right key. So you have to use the right key. You have to check if this is the key, subkey, if this is the subkey you used for the encryption. Well, I know, but it really matters. I don't have big plans to this project, except that I'm working on the new version. Actually, maybe at some day I will release the sources. I don't know. Now let's back for the beginning of this presentation for a while. Remember this? Dumb. After I finished the OpenPGP, I created the application that is driven by the OpenPGP framework. So I created the privacy app because I believe there must be easier way to deal with PGP. I believe so. This is how the application looks like. So comparing to what you saw at the beginning, you just enter the email, enter the message, and press send. And this is all, actually. Message will be encrypted and sent to the receiver. This is how I done this. There are the key servers. The key servers are the servers where everybody can upload the public key. It is public, available. Everybody can access them. So I wrote the app the way that app asks the key server for the email address. If it is available, just take this public key and use by the app. Seamless, and it works. So there is a profit. A privacy application is encryptor at the moment, so you can encrypt data. However, you cannot decrypt yet. And it's driven by Objective-PGP. So the PGP is a protocol, so it's kind of abstraction. The other night I thought, how about if I go a deeper? What if I try implement some cryptography algorithm? So I did. At this time in Swift. So there's a crypto Swift. And Swift we trust, said no one ever. Why? Actually, 5 minutes after I published the crypto Swift to the public, I had this question in the GitHub issues. Why? Guys, why have you done it? Well, my answer is because I can, and because I'm an engineer, so I have to challenge myself constantly, and because I'm curious what's really inside. What's inside AES, what's inside Chacha, what is inside MD5? Well, what is there? So this is what is inside AES. I mentioned this is the advanced decryption standard. This is a software implementation. I can't use the hardware acceleration because Swift cannot access the assembler, right? So I had to implement it all in the software. Thanks to this, it's slower, of course. The next is Chacha 2.0. Has anybody heard about Chacha Cipher? No? Okay, you should. Because Chacha is a choice of Apple and Google to replace AES soon. Actually, Chacha is used in HomeKit and by Apple, and Google use it with the communication between Android Chrome and Google Sites. In TLS stack, they replace AES with Chacha. Why? Because Chacha is damn fast. There is no matrix operation, it's only XOR operations, and it's really, really fast. It was invented to be fast on mobile devices, and it is. I believe it is the future. There are hashes. Well, everybody know MD5. You shouldn't use that, of course, but everybody know that. You should use this one. This should be. Why you shouldn't use MD5? There was recently on Hacker News a post about PHP, right, and the collision. You saw that? Not? MD5 is not reliable. There's authenticators, Poly and HMAC. You might heard of HMAC. Authenticators is an algorithm to set who actually encrypt this message shortly. And there's ACB. This is important actually. ACB, CBC, CBF. Three operation modes of block ciphers. So whenever you write an encryption, let's say you encrypt data with AES, at some point there will be question, should I use CBC, cipher blockchaining, CFB, cipher feedback, ACB, electronic code book, and you will choose probably ACB, and you should not. This is the easiest one, but it's the less secure. You should not actually. Using the ACB will expose some information about encrypted data. This is working this. The block cipher only encrypt one block at a time, so let's say 64 bits, right? Whatever. With the ACB, you encrypt this block, encrypt block, one, next, concatenate, and this is your output. With the CBC, you take the first and use the encrypted data as an input to the operation of encryption for the next block. It matters. So never use ACB. PKCS, really, PKCS7 is about padding, because data have to be padded to length of the block. That's all you have to know. So, at the moment I maintain CryptoSwift. There's a lot of fundamental questions about how to use the ciphers, how to use AES. Sometimes there's a code in PHP I have to write to help. A lot of people misuse AES, but asking is fine, so it always ends in a good way. And well, not really contribute back because everybody thinks it's too hard. It's not. But everybody thinks that implementing, I don't know, AES is too hard. The way to implement such a thing is you have to take a documentation and implement it, right? Ciphers, they have the best and most detailed documentation, because this is how they were invented, to be precise. So, well, you have to just take it and implement it. It shouldn't be that hard. There's no RSA. From time to time I have a question about RSA. I would really love to see the addition of RSA public key encryption. Yeah, that would be nice. That would be really nice. But RSA is hard, actually. It requires, to implement RSA, I have to first implement the big integers, right? It's not available in Swift yet, so I have to implement big integers, then I can implement RSA. A lot of people ask about compatibility between Android, iOS, and PHP. Of course, it is fully compatible. However, some libraries somehow do some extensions to the output message. So you should worry about it. It's not just output of AES. There's an output of AES, plus we add some, let's say, key or initialization vector or whatever, something. Then it won't be compatible. This is the example of a really great question. It was like, I don't know, 30 responses. The guy asked me about the PGP, how he can deal with Swift, CryptoSwift and PGP, and we end up with a PHP code. Well, it was refreshing, actually. So, this is the end, and I want to encourage you to build the things, actually. So, there's nothing that are too hard to do. We are programmers. Thank you.
Okay. Are there any questions? Yeah, there are questions. Haha, not so fast. So, maybe I'll pass the microphone. Yeah.
The source is closed. How can we trust that there are no errors and trust the software, especially for character?
Yeah. When it comes to PGP, it's not algorithms, right? It's just a protocol. And as I said, you can ask for the sources. You can ask me just for the sources, and I can show you. Yeah. There was a few people who asked, and they saw it, and that's all. Yeah, that would be great. Nobody did it. Nobody did it to the CryptoSwift, actually. If there's anybody who can do such a thing, well, just let me know. But nobody did it. Any questions? Yeah, Dan.
How hard was it to photography in the case? Because we described the file abstraction as a part of file abstraction, right? So let's go down to unsafe pointers and so on. How hard was it?
Yeah, I didn't go with unsafe pointers. It was my choice. So it is all in the types of Swift. So there's arrays of bytes. There's no chunk of memory I work with. It's byte by byte, and I do the matrix operation, XORs, and so on. It wasn't so hard. Actually, it was not so hard. But no, performance is bad. No, actually the performance for AES is bad. I don't know why, and I think it's because the array operations are very slow. I don't know how to make it faster today. I would, if I use the chunk of memory and the operation on the memory, it would be done fast, but I didn't. So accessing to the bytes, it's visible in the instruments. It's not. I'm not proud of it, but I don't know how to make it faster. Maybe some of you will. Okay. License of CryptoSwift. Objective PGP. I don't remember. It's on GitHub. No, I don't remember. It's a cloud source. I believe the license itself is based on Zlib license. Not so common, but it is. Okay. Okay, thank you.